So for those of you who don't know me, I'm Diego Tavares. I'm a lead software engineer here at Sony Pictures ImageWorks, and I'm the TSC chairman for OpenCue since last year, and I'll be presenting OpenCue. And for those of you who don't know, OpenCue is a render farm management system. What this is a tool, a service that allows workloads from render farm systems to be rendered on a cluster of computers, aka render farm. So work that has been developed by an artist instead of being rendered on its own workstation can be broken down into pieces and sent to a render farm to render on a cluster environment by several computers. And OpenCue was initially developed at ImageWorks in 2007, so a long time ago, and it was named Q3 back then. And on 2019, it became an adopted ESWF project. I think it was the fourth project to be adopted by ESWF, so we're very early on this. It has been used at ImageWorks since 2009 to render all of our work, so over 50 movies, probably some of them you have seen on the movies, were completely rendered using OpenCue. And as an open source project, we have a community maintaining it. The community has as TSC members myself, Diego Tavares from ImageWorks, Jimmy Christensen from Ghost VFX, and Ramon Figueiredo also from ImageWorks. And we have more than 30, 40 contributors over the years. Here's the list of the top contributors over the last 2 years. And this list goes not only through different companies, but it also comes from different industries that are contributing to the project. Because we have OpenCue being used not only to render farm or company studio work, but also on companies like Facebook or even stores online using OpenCue to render their PCs or to render different workloads that are not even rendering, but that use OpenCue as a means to distribute workloads. And we are currently searching for new TSC members. So if you are interested, please scan the QR code to join our Slack channel. There we share the latest news, the upcoming meetings. And to become a TSC member, you have to have contributed to multiple modules of the project. You have to be active on the TSC biweekly meetings and have some experience in a production render farm environment. So please join. We are looking for new members. And last year, when I took over the chair position on OpenCue, on the TSC OpenCue, we had some challenges. And the main one was the number of open PRs, finished PRs. Some of them were stale, some of them were under development. And that led the project to a low retention rate, meaning people who contributed to the project were less likely to come back and contribute again, especially because they didn't see their work coming into master, into a working solution, into the version everybody's using. And a different problem that we had is that most of the contributions were going to a single module, which was the easiest module to contribute to, but they didn't expand or didn't invite people to contribute to different modules. And this was a problem on documentation. This was a problem on introducing people to the project. And these were the challenges that I was facing last year. And as my first goal when I became the TC head, I wanted to clean up the PRs and issues that we had in the project and to improve our PR reviewing system or the protocol, because the system is GitHub. But when looking at the metrics, things were not good. So an average time to merge a PR was 3 months, which is insane. So you come to OpenCue, post a suggestion, work on your code, and wait up to 3 months to have your change accepted or even not accepted, which is a long time. So when you see probably a request for change or it being accepted, you already forgot about the project, you already forgot about what you did. So one thing that happened after cleaning up all the PRs and getting the whole team into the model of always reviewing PRs and following up with what was going on the project, we greatly reduce the time to merge. So now it takes, in average, 8 days to merge a PR. So the PR will be picked up in 1 day, in opposed to 4 days before. It would take less than 3 days for the first review, which used to take almost 2 months. And the PR will get accepted usually in less than 4 days. So in a week, you probably see your change, make it into production, or even have a feedback to continue to work on it. With this, as expected, our retention, which was plummeting, it was at 12% and going down probably to 0, went to almost 100 or too close to 100. Right now, we are averaging 80% retention, meaning people who contribute to the project are more likely to continue contributing to the project and becoming a part of the community, not as a single contributor. And you think that, okay, this only happens because you have less PRs, and probably there, after so long without merging PRs, people give up on the project and the number of PRs reduce. No, that's not what happened. So we went from 88 PRs in 1 year to 515. That's a 485% increase, which is great. So we have more traction in the project, more changes being made, new features being developed, and the community became active again. And with all the contributions, what changed? So what changed over the last year? I have some things to present. I'll play a video that was supposed to have an audio, but Zoom didn't want to cooperate, or my MacBook didn't want to cooperate. I'll have to speak on top of the video. But one of the features we developed was QWeb. QWeb, it's a new visual interface for OpenCue. So OpenCue, before QWeb, the only way to interact with OpenCue visually was using a Qt-based application that runs on Linux, Windows, or Mac. And this Qt-based application is good, but it requires that your machine is at the same environment or inside of your network environment to have access to everything. And now we have developed QWeb, which is a web interface that integrates most of the features of the basic Q GUI that runs on Qt. And I'll take you guys to a tour on the tool. First, it has a login, a sign-in webpage that integrates with Okta, Google, and GitHub. So when installing QWeb, you have to configure your signing service, which is very simple. It's just getting the tokens and the key and integrating that into the code base. And with that, your users will be able to sign in. And on the basic interface, you can see the jobs that are running under your name. You can filter change the columns that you want to see. You have actions to queue a job, edit a frame, pause a frame, unpause, everything that you have access to on the Qt-based application. You can expand a job to see its layers and frames, to see exactly the specific commands that are running. And you have every information you might need about the frame, when you started, when you stopped. Everything's paginated, so you're not loading hundreds of frames into a single interface, which makes the interface very responsive. And when you click on a specific frame, you can see the logs for the frame. This example doesn't have a log, unfortunately, but you can see the logs of the process that is running behind the frame. So you can catch errors and follow through on what's going on. You can also filter by state, which is simple. And just wait. And it also has a dark mode. So for those of you who don't like to look at bright screens all day, which I'm one of them, you have a dark mode. And you can decide which jobs you want to see. So you don't have to always be seeing all of your jobs or all of your show jobs. You can simply unmonitor the jobs you want and use the search bar to search for this specific job. So I'll move it through a little bit. So you can search for a specific job and click the job to start monitoring those jobs. And the state, it's always saved. So when you open again, you'll have the same list of monitored jobs, plus your new jobs that got added to the queue. So that's QWeb, and it's available today. You can see it's one of the modules that we provide as part of our BDs. All right, next feature, Containerize jobs. So what is this? In summary, Docker. So OpenCue now allows, as an optional feature, to run frames on a Docker environment. So basically, a render node can declare on its configuration what images it has available or what images it is able to run. And a job can define what Docker image it wants to run on. So for example, you can have an image with a CentOS 7 environment with all your Maya dependencies, all your libraries for Maya. And you can say that this render node, in this example, Rocky 9 render node, has this image available. and you can create a job 1, for example, that requires that image. And OpenCue will only dispatch that job to render node that contains the right image, and you run the job inside of the container. So why that? What was the inspiration behind it, or what was the motivation behind it? So we at ImageWorks were in near past having to migrate from Rails 7 to Rocky 9 to Rails 9, as most of the industry had. And on this migration, if you think of an active render farm with shows running, you can have shows that are running on CentOS 7, on Rails 7. You can have new shows running on Rails 9. And those shows are usually sharing the same farm, because usually OpenCue not requires, but it recommends that you share your resources just to avoid wasting resources for allocating resources for specific shows. But if you have a situation where you have two different OSs, you end up having to segregate your farm, saying this portion of the farm, it's the old version, and this portion is the new version. And you have to say this show only uses the new version, this show only uses the old version. This is if you have shows using a single version. You can even have shows that are using multiple versions of OSs. And this becomes tricky and becomes wasteful if you think that you are having to segregate your farm. But with this solution, with the containerized jobs, we were able to aggregate our entire farm to Rails 9 and have a Rails 7 image available in all the nodes. This means that jobs that were being launched by the old shows would require a Rails 7 image, and they will run on top of Rails 7 on a new Rails 9 image, on a new Rails 9 host. So with this, we didn't have to segregate the farm. We have a single render farm within the same OS everywhere. A thin layer, meaning that the OS didn't need to have everything that is required for a job, but the image themselves will have everything that was required for every kind of job. Another use case for this new feature is handling jobs with odd dependencies. So once in a while, there comes a job with very odd dependencies. They require a newer version of a library or a very old version of something that is incompatible with everything else. So what usually happens is that the systems team on the company, on the studio, will have to set up a specific pool of machines with that environment, which is wasteful again, because you have to segregate the farm, and those hosts will only run that workload. But with this new solution, you can simply say that those jobs require the Docker image that contains the odd dependencies. And within the same render farm, you can make a job execute the specific dependencies on its own container. And another use case, the last one, it's re-executing old jobs on the supported OSs. So let's pretend you have a show that wrapped 10 years ago. So it was probably running on Fedora 13, which is no longer supported by anyone. And it was running old versions of libraries. Python 2.7 was running old versions of everything, versions that are probably not even available on the market. But you have to re-render a job, for example, for a commercial or to be reused on a new movie that makes reference to an old movie. In that case, what you end up having to do is to try to configure an old machine or a new machine with everything old, which can be a pain. So if we use the Dockerized environment, what we're able to do is to create an image with that requirement, or even for a show that is being executed today, you can create an image for that show today and archive that image with the show backups. So 10 years from now, if you need to re-render it, you have the image with everything that you needed with all the dependencies, and you don't have to reconfigure everything from scratch. The Docker images there can be simply started inside of a new container. All right, Rust RQD. So RQD is the monitoring agent, is the agent that runs on every node of a render farm. And this module used to be written in Python, and it has been completely rewritten in Rust. First, why are we writing it if it works? So this module, RQD in Python, accumulated 12 plus years of code changes since the inception of OpenCue. And the code base was well designed, but it was designed 12 years ago. And I've been maintaining it for 5 years, and I say it was a pain to maintain. It was hard to maintain, especially because it has had big functions with a lot of different branches. You had large Python files, and it was handling different threads in Python, which is not always optimal. So what ended up happening is that this module became the least touched module on OpenCue. So it became precious, meaning nobody wanted to touch it. If you touch it, you be sure to test 100 times every different condition, execute a unit test, integration test, and manual tests, and be 100% sure it works, because if RQD breaks, deploying it, it's hard because it has to go to all the render farm, and it impacts the entire system, and errors on RQD are usually hard to find. So we decided to re-implement the whole solution in Rust without changing its functionality. And one thing that we noticed is that this Python version was initially written for a time when 2 or 4 cores on a 20 gigabytes server was the norm. So something that we have on a Raspberry Pi today was what we were using 20 years ago to render. So the design was not taking into account hosts with hundreds of cores. Although RQD works well with 100 cores, it was not stable. So we noticed that with more than 100 cores, we start to see memory leaks. We start to see spikes in memory. And what ended up happening is that we created a protocol to restart RQD every 1 or 2 months on the entire farm, which is costly. And this was the motivation to re-implement the entire code base. Why Rust? To start with, Rust, it's getting traction on the VFX industry. A lot of new projects are starting in Rust. Some projects migrated to Rust recently. So it's easy to find developers that are interested in learning and contributing in Rust. And Rust is very strong in low-level libraries. So it has a very easy to interact libc and Docker library, which is something that we use on RQD. Even easier to use than Python. So it was one of the main things that motivated Rust as the choice. So this new version is already on production at ImageWorks. Over the last 2 months, it has been deployed in, I think we are close to 300 hosts, but we are migrating the entire farm to this new version. And what we noticed as quantitative gains is that this version is has a 5 times smaller memory footprint. So impacts the machines way less than the old one. It uses half the CPU and has no spikes. And all this while running double the sampling rate. So we are measuring what's happening on the host more accurately and what's happening on jobs more accurately, and still wasting way less resources. And qualitative gains. So as most of you might know, Rust is very strong on memory management. So there are no memory leaks, and this is checked at compile time. Rust have a way safer async environment. So if you have worked with async code in Python, or at least threads in Python, it can get complicated very fast, especially if you're sharing memory, which is required on RQD, as it has to be monitoring both the state of the machine, all the processes that are running, and at the same time, keeping track of some other underlying resources and syncing everything to send to Qbot, to the server. So it's natively an async product, and written in Python means that it was very hard to maintain, very hard to understand what was happening where, which was one of the main barriers to entry on the module for people contributing. And as Rust is strongly typed, it has a great compiler. We now are able to catch way more errors at compile time before even moving to the test phase. All right, so the new version is, the idea is that it will replace the old one. So as of now, Python is still the official version, and Rust is officially supported. So if you want to migrate to the Rust RQD now, you can. Beginning of next year, Python becomes a supported version and Rust becomes official. What this means is that changes will come first to the Rust module and be propagated to Python afterwards. And mid next year, we are deprecating the Python RQD. It doesn't mean that we are removing it from the code base yet. It means that we no longer supported. So changes will go to Rust first. If required, they might go to the Python version, but we are no longer committed to the Python RQD. If you have any concerns, or if anyone on the community has concerns about migrating or have any problems, of course, all of those dates are not written on stone. They can be changed, and we are open to listening to the community. Next feature that was implemented last year, Grafana Loki. So Loki is a log aggregation system, and now it integrates very well out of the box with OpenCue. First, I'll explain how logging works on OpenCue. So if a job is running on a render node that only has a local file system, the log will be written to the file system. So it's a log file that has a name based on the job and frame name. And the only way to see the log from the Qt interface will be to run that Qt interface on the machine that executed the job, which is not optimal, and it's not the way we recommend running OpenCue. What usually happens on studios is that they will have a shared file system, something like NFS, and render nodes will be writing logs to NFS, or to the shared file system, and the Qt-based application reads from the file system, from the NFS. So we can have all the logs on a single location and access those logs that way. It works well, but it has its limitations. And with Loki, what happens on this very crowded slide, sorry for that, is that render nodes now can write logs to a Loki server. So instead of writing to a file, they will be sending the logs to a Loki server. The Loki server stores the logs on journals, and the OpenCue application uses the Loki API to access the logs. So for the user on the Qt application, nothing changes. It's still able to see the log the same way. You probably wouldn't notice that the logs are being served from a different location. But now with Loki, we have Grafana being able to read the logs. And the Grafana Loki plugin is very powerful. So you can query logs using the Grafana query syntax. So here you're searching for logs with information on the name, and you're just grouping them in 1 to 9 milliseconds. You can create charts on top of logs. You can create alerts on top of logs. So you can say that if a specific message happens with this frequency, send an alert to a different system or to an email. So it brings the power of observability into the logs of OpenCue, which is pretty good. And this comes out of the box. The only thing required is to have a Loki server. So if you head into Grafana Loki, there's a very simple user guide on how to set up Loki in your environment. And as soon as you have a server up, you can set up QBot, the server module of OpenCue, with a path to the server, and you will send all the logs to that server. It's as simple as that. Next feature, pip packages, which is not a feature, but something we are releasing. So prior to, or as of now, OpenCue doesn't have pip packages available. So if you want to install the Python packages on your studio, you have to not build, but you have to package them yourselves. You have to download the source codes from our repo and run the build scripts to generate the pipe packages. This is changing now. On the probably next week or 2 weeks from now, we are having pip packages published to a public pip repo, meaning you can simply pip install OpenCue RQD and you get your package installed. So it's way simpler, and it's way easier for new studios or people who just want to experiment with OpenCue without having to commit to download the source, understand how to build it, or things like that. And I think the last feature, a new documentation. As I said, documentation was a big problem. It's not that we didn't have documentation, but it was not well organized. And it was documentation for mostly programmers using OpenCue. So now we have a new documentation website. It's currently available at this link. I'll share the presentation afterwards. You have access to the link, but it will soon become available on the OpenCue.io website. On this new website, you have video tutorials, guidelines, release notes, user guides, everything that you need to understand what OpenCue is and how to run OpenCue on your environment, and even how to integrate with your code base if you want to interact with OpenCue API. And yeah, now we finish everything that we got developed last year. Let's move on to what we're planning to work on the following year, or things that we are already working on that hasn't been released yet. The first of them is distributed booking. So OpenCue works pretty well for a render farm that has 100,000 cores or less. So if you go beyond 100,000 cores, you start to see bottlenecks, and the main one is on the database. This is because this is main cause by how OpenCue was designed. So right now, OpenCue has the RQD agent that runs on every render node that reports the stats to the server, to the QBot, the Java server. And the Java server saves the state to the database, and based on that, queries for what's the best job to execute on that server, and dispatches that job to execute on the node. So that's how it works today. It works well, but the bottleneck is on the database. Querying for what job fits this server or this render node is an expensive query because it has to take into consideration allocations, subscriptions, limits, and a ton of different things. So it's a very expensive query. So if you start to see slowness on the system, the first thing you would consider is scaling up the Java server, which is something you can do. But at some point, you hit a wall on the performance of your database. And that wall comes fast when you go beyond 100,000 cores, especially if you have very large jobs. So this is the problem. And one restriction we have for this new solution is that it has to be optional. Just because this solution is, although it doesn't work well for very large render farms, it works very well for small and medium-sized render farms, and even large but not huge render farms. And it's very simple to set up. It's a simple Java server, a database, and a Python, now a Rust agent. So the new solution needs to take into consideration that some users still want to use the simple version, but big studios might want to use the newer solution, which is this one that's been proposed. And this is just a proposal, nothing is written on stone. Everything here can and might probably will change. But what we are thinking of is that we'll keep most of the logic unchanged. So RQD continues to report back to QBot. QBot continues to save the state to the database, but we don't have QBot trying to dispatch jobs to a server. So the expensive query that used to happen to search for what job should be dispatched, that doesn't happen anymore. What we have now is a single job monitor that queries the database for the pending jobs on a schedule. So every 5 seconds, every 2 seconds, gets the list of pending jobs and streams that list to a message broker, something like Kafka or RabbitMQ. So this message broker will contain topics with the jobs that are pending. With that, we can have several schedulers consuming from the broker and booking jobs to the render nodes. So with this, we eliminate the expensive query here, and we have a single module making a cheaper query from time to time. And we have the scheduler making a very cheap query to find which host can execute the job. And with this, we can scale up the scheduler. And the database stopped being the bottleneck because we have a message broker streaming the jobs that are pending. So this is the plan. It might change, as I said, but we are already working on this. And the promise is that although more complicated to set up because it requires more services, it would be scalable. So it will make more sense for large render farms. And the next feature we want to work on, this one nobody has started working yet. So if anyone is interested in tackling this, just reach out to us. It's farm autoscaling. So OpenCue was developed with on-premise in mind because it's what it was developed on. So right now we relies on every host sending a report every X seconds to the server, or else the host is considered to be offline. So if a render node is shut down, it is offline and it cannot be turned on by OpenCue. So what studios that use OpenCue in the cloud usually do, they have one external service that connects to the database and does the job of scaling up and down the farm. So what we want to do is to integrate that inside of OpenCue. OpenCue will become able to shut down and boot machines automatically based on the status of the queue. So if we have too many jobs waiting, if the speed, the pressure on the job queue is high, we can scale up the farm. If it's low, we can scale down idle hosts. And one thing we want for this is that it is cloud agnostic. So we will work with all the cloud providers, and that it also works with on-prem. So you can use iDRAC or other similar hardware control solutions to dispatch or to send shutdown or boot commands to on-prem machines using the same logic. So this will bring OpenCue to the cloud on a more friendly way. And that's it. That was the last slide. If you have any questions, just let me know, or you can ask them live. And I'll stop sharing to see if we have any questions on the chat. All right. If we don't have any questions, I think we're done. A little bit early, but yeah. Oh, I think maybe I see something on the chat. 1 second. What? So the question from Steven Dugaro, sorry if I butcher your name. What sets OpenCue apart is how sophisticated it renders dependency management is for large jobs. How is this supported with QWeb? So QWeb uses the same, if I remember correctly, it uses the same, it reads the same logic of dependencies from the current Qt based QE. So you're supposed to have the same level of control over dependencies that you have on Qt. And the idea is that any advancements we make on the Qt-based application will make it through to the web version of QWeb.
So Diego,
Right.
before we go, I have a question. So can you go back to the segment of your presentation where you had this increase in PR from 80 to 500? I missed the exact number, and I want to keep.
I think this one. Yeah.
Yes. Yeah, that's pretty amazing.
Yeah, it was impressive when we were looking back because we didn't see this coming because we were simply reviewing PRs and working on the project. And when we come to make a review at the end of the year, we saw the amount of PRs that were coming through and still seeing that the project was stable. It was impressive. And one thing that we didn't have last year that I forgot to mention is that I think on last SIGGRAPH, this was still the case. ImageWorks was not using the exact same version of OpenCue as was made available online. Not that we were making changes and not sharing the changes, but it was hard to conciliate the internal specific things with the open source version. And a lot of work, like months of work, was being put on to make it so that everything that we do that is specific to ImageWorks is configurable now and available for everybody else. So a portion of those PRs made the code compatible with what we need, and now we get the code from open source, build and run. So there's nothing specific to ImageWorks. We use this exact same version that is made available online.
That's great. Thank you.
No worries. So we have one question from Erwan Leroy. Have you heard of anyone using OpenCue and Docker containers alongside with REST? So we had people using OpenCue with REST, and we have been using OpenCue with containers, but not both at the same time. Yeah, I don't think we have seen that use case, but I don't see why it would be a problem. So if your container contains all the dependencies that you need for your REST setup, it should work out the box. But one thing I can say is that I haven't seen that many studios or any people using a render farm with Docker containers. So our use case was one of the first times we saw that on production and it worked fine, but it's still some territory that hasn't been explored very well. And I feel like there's a lot to learn there. Right. If we don't have questions, I think we're done. Thank you, guys. See ya.